Section 5, the USB-C connector. This is the connector that you'll be getting with your kit. It may or may not have an end connector on it. This is a smaller connector than I've been providing with the kit, and it's a JST-PH connector. I've started including this connector, the mating connector that goes on the circuit board in the kits that are going out shortly, so that you can avoid having to cut this wire off. As you can see with the printed adapter here, it will fit through the printed adapter, so there's no reason to remove it if you want to use this on the board. However, the mating connector that gets soldered on the board will be soldered with the keyed cutout portion for it facing the rear, which is the opposite of how the other connectors on the board have been placed on it for polarity purposes. The reason is the hot wire, the red wire positive that comes from the port of the wall, is on the left side when the keyed portion of the connector is at the back. So that's just something to pay attention to if you want to use the smaller mating connector that goes on the circuit board. Otherwise, if you want to avoid all confusion, we're going to drive on here with the video and set up to do the USB-C port on the adapter and the wiring for it. So the first step is, one, make sure you've printed the adapter specifically for the USB-C port. The larger face of it faces outward from the box and the smaller face is inward. You can see on the Z-seam here, there are going to be some little nubs and stuff from the Z-seam. I've been using random for the seam just because it seems like it distributes the mess. Here from the box, if I can get it centered or close enough. There we go. Facing outward, you want to first make sure, test fit the connector. It will squish in there, but it's very tight, a little snug because of the seam there. So what I'm going to do is just take a nail file. I just like to sand towards the inside of the piece. So from the outer side, swiping this direction with the sand. As you can see, the face is untouched, so I'll be able to smooth out the nubs. I'll be able to smooth out the nubs and get that smoothed down without marring the outer face of it. And you can just go all around. Again, the sides are not, they're not superficial. They're not even going to be seen on the outside. So it's okay to take the sander to them. I wouldn't do that to almost any place on the outside of the box, however, unless it was absolutely necessary as a result of your print. Trying to get this centered while I do this is not tricky. So just a little bit of light sanding there, and we'll see now with the test fit going in there. It is smoother now, and there's a stop limit line printed into the hole for it, so it won't go further than that. And that's a nice smooth fit. I didn't want to make it too easy a fit, because then you have a lot of gaps at the corners and maybe the sides, and I want it to be snug. So even if the hot glue fails, the whole thing's going to hold solid in place and look fairly tight. So just push out from the underside there. Again, a snug fit is okay. Push out so it comes out nice and even. And now this adapter is prepped for the rest of this portion of the build. The next step for this build is going to be cutting the cord off this adapter, which I'm just going to cut it about 1 inch. You can go 2 inches if you want. What we're just trying to do is make sure we don't have a lot of slack left in there, a lot of line left, because we're going to be soldering on thicker wires, which are going to carry power a little bit better with less resistance and heating. So I get my trusty wire strippers. Here we go. And we're going to give a twist. Like I always say, strip, twist, flux, and tin. Trying to get it so none of the stranded wire bits are splayed out. So for this portion of the build, you want to make sure you've got a couple of the short segments of the blue heat shrink. And we've already stripped these wires. We're going to dip them in my flux and get my solder ready. I like to have the solder sticking up a little bit in the air so it's easier to dab the tip of the iron on it. There we go, there's plenty. And now I'm just going to give it some, hit it with a little bit of solder. There we go, I can see it tinned. It's nice to see when the color changes. There we go. Shouldn't take that much effort, but I'm kind of anal about this. Now we've taken care of that part. We're going to take two of the short wire, pre-pinned wires that came with the kit. These just happen to be blue and white. The point is that you get the light and dark wires so that it's easy to identify which is ground and which is going to be the power. So I'm just cutting both those wires to about 4 inches. Make a note of this. A little bit longer is okay. I do try to minimize how much extra wiring I have for these because it gets pretty crowded inside the brain box. Now we're gonna strip the ends to the same length that we did. Strip as much as you did for the USB-C connector. You can twist, flux, and tin. Just dip it in my flux. There we go. Clean the tip. Get a healthy amount of flux on the tip of the iron, and I just slowly draw it along the wire. I want to make sure that's tinned the whole way to make the splicing a lot easier. There we go. I think that'll do. A little dab will do her. And now putting the heat shrink on the wire right now is not necessary because we not have the housing on for this step. So there's no worries about getting it in through the adapter later. But you do want to make sure you get the wires through the adapter before you do the housing portion. And now I'm going to set these wires up in the holder to do the solder. So here we go. We're going to try, not going to try, we're going to do. Do or do not. There is no try. I do a terrible Yoda, but I do try my best. There you go. I already had solder on the tip of the iron, and the wires were already tinned, so that went nice and smooth. Now I'm gonna take this out and flip it around. I think. No. Nope. That's just gonna make it just as hard. So I'm gonna do the negative wire next, and I'll have to get this one that's already done out of the way. Spin that little guy into place. Get this guy on here. Try to get these lined up a little bit. There we go. All right. A little more solder to the tip. As you can see, the jaws, those alligator clips. Oh, that's nice solder. Those alligator clips of my helping hands here are, I put heat shrink on there because they came as bare metal, but I don't like to damage the part or the wiring too much when I put the stuff in there to hold. So I just put some heat shrink on there and shrunk it down so it helps. I might put another layer in there at some time, but I don't want to lose too much distance because these gator clips don't open up wildly far. So as you can see now we got a good joint, and we're going to put on the heat shrink. Going to slide it on from the ends. They barely slide on. I remember that from before. Or I could actually say I did forget totally and I was lazy. And it's always good to slide heat shrink on before you do the soldering. I don't know why that's so challenging for me to remember. I've found that if I only cover one of the joins, do one join at a time and take the heat shrink away from the other side, it's easier to tell where the center of that join is. There I'm using the side, lower the temp on my iron, and I'm kind of holding the heat shrink in place with the tip of my fingers to try to get it to hold still. Again, be careful not to touch the housing of the USB-C connector or the insulation of the wires. I'm just going to kind of twist it around as I have the heat tip on there. And there, it's shrunk nicely. Doesn't have to be perfect. It just needs to make sure that the wires, the joint is not exposed. We don't want any shorts. Yeah, the second one's might be a better job of concealing, of centering, or not. Did that look close to the fingers? Don't worry for me. There's lots of little heat burn injuries from lots of soldering if you do enough. You would think you learn at some point. There we go. So this is nice. It's fine. We've covered the open wires, so there won't be any shorts, and we don't like open bare wires with power on them inside the box. We're going to be using the battery box for testing, so we can go ahead and put the connector on now if we want. Hopefully you made sure to solder the light to light and the dark to dark wires. So we're going to take the adapter here and identify the larger opening side and put the wires through from the larger opening side to smaller. And now we're going to meet some resistance once the port gets close into the adapter. It'll take some squeezing, and it may take, there it popped in. There was a lot of force to pop it in, but once it's in there, it's not coming out. In fact, it does feel like a snug fit. I'm pushing on the wires from the back side, and you can see there's no movement from the port on the front side. This makes it a lot better than my very first draft version. At the end, we're still going to be doing some hot glue inside. You're going to want hot glue inside on the inside portion there, just to make sure that when you're unplugging the cord, that the whole thing doesn't end up having a little bit of wobble. It's nice to feel a nice tight connection. And after that, you can go ahead and put the connector housing on there. And the connector housing, we want to face with the keyed portion. Get that centered. With the keyed portion facing you, the light wire goes on the left, and the spine of that pin goes at the back. So it's going in from the left, and the spine of the back, and it's clicked in there. It's a silent clicker. And there we go. There we go. I push in with a little bit of force, and it clicks into place. And as you see there, you can see the wires are pushed most or all the way in there. And later on at the final build assembly, when we do a lot of hot gluing, you're going to end up hot gluing the top of this, the top of the housing and the wires, so that they don't come loose or slip out incidentally when you're working the project, or pulling things off later if you have to redo something. The last step in this process is to test our gear. So we're going to be testing the power adapter, the USB-C adapter. I've got this plugged into my laptop for 5 volts. and I'm just going to plug it in there. The housing's already on. I think I warned against that in the PDF guide. But you can still probe this portion. You can just use the tabs on the back to get access with your multimeter. I'm going to set it to DC volts. There we go. And get everything worked out. And I'm just going to use the open tab on the back to get my probe in there to touch. And the dark probe on the dark wire. And the light probe on the light wire. And we'll see what that, yep, 5.1 volts. That's great. Now, if you see that it's minus 5 volts, then something's backwards. You soldered the wire on backwards, light to dark. So it'll look like that. Always look for the minus sign. That's the polarity. You got to make sure the polarity is right when we power up that board the first time. And that means the polarity for everything has to be right. Otherwise, something is not going to work or nothing will work. And again, don't try using a high wattage, high power USB wall block because there will be problems. Just use a normal 5 volt block, or you might encounter problems with it not seeming like it's working.